So let's try a problem with that. Okay. So for example, look here. Okay, how many atoms are in zero point 0.5 moles of aluminum? All right, if you look at this problem right here, guys, there is no mention of the word grams. It never mentioned anything about grams. You see it? Okay, but you do see the word atoms. Okay, and remember this, as soon as you see the word atoms, particles, or molecules, you need to remember that the conversion factor that you need is 1 mole, okay, of whatever, in our case, it's aluminum, okay, is equals to 6.022 times 10, okay, to the 23rd power, okay. In our case, it's atoms, all right? Whatever is the keyword, that's the equivalent for the other side. So remember, before it was 1 mole is equals to grams. Now it's 1 mole equals to, if the keyword's atom, therefore you're looking at atoms, AL. See it? All right, and that's your conversion factor that you need. Okay, so how do you solve this? It's the same exact way we've been solving it. Set it up the same way. Draw the grids. Okay, take out the bottom. There's nothing here. Write the given. In our case, the given is zero point 0.5 moles of aluminum. Okay, same way you decide on which one goes on the top and which one goes at the bottom. Look at the unit. The unit diagonally across has to be the same. So look, moles AL, so this has to be moles AL as well. All right. So where do you get that? Again, look at your conversion factor. Which one has mole AL? There's only two of them. So if you look closely, you should see that one side is 1 mole AL. And what's on the other side? It's the 6.022 times 10. But since you can't write down a superscript, you have to do a hat sign like this. Okay, 23. All right. Okay. And this is where it gets crazy now. All right. Ready? All right. And now we have to multiply everything at the top. So y'all look, I have to multiply 0 0.5 by 6.022 times 10 to the 23rd power. How do you put that in the calculator? All right, y'all focus, all right? Ready? Here we go. Let's go up to the calculator. Up to the calculator. You see this calculator right here? So we need to put in 0 0.5. 0 0.5 times, and that was 6.022, right? 6.022. And that was times 10 to the 23rd. So how do you put in the times 10 to the 23rd? You just press E. See that little button that says E? You see that E sign? Okay. You go click on that. Okay. You go click on that, and that is your times 10. So I click on it. Okay. And then you just put in the exponent. So this is 23. Okay. All right. Oh, did I click it? Did I click on the wrong one? Oh, I can't see it from here. Okay. Let's clear it out. I think I clicked the wrong one. I didn't click on the right one. So let's do it again. 0 0.5 times 6.022. And where's that letter E? It's at the top, right? This E, right? Times E. Did I click something else again? Can't see this part. All right, 0 0.5 times 6.022. And this is the E, right? E, 23. Oh, okay. That's correct now. So you see that? So 0 0.5 times 6.022 times 10 to the 23rd. So that's how you put it in this calculator. Right. If you have a better calculator, go use that better calculator, because this one literally sucks for scientific notation. If you have an iPhone, hey, if you have an iPhone or an Android like mine, for example, this one right here, if you go turn it sideways, it should turn into a scientific calculator if it's unlocked, like this. All right, and you also have that E right there at the bottom. All right, okay. So click on enter and you get a very big number, huge number. Okay, so how do you get the scientific notation out of this. You just need to move the decimal place. Okay, just move the decimal place back from the very right side. So just count until you only have one number before it. So let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Dear Lord. Okay, so it's 3.011 times 10 to the 23rd power. Okay, and that was the answer to the top. Okay, or again, you can just use a fancier calculator, and this would make your life a lot easier. So let's go down here again and do it again. All right, so, oops, sorry. This one right here, again, the given was 0.5. This was 1 mole, and this was 6.022 times 10. And again, you can't put that, so hat sign, 23. All right, the moles AL canceled out, and we multiplied the top, we got 3.11 times 10, 3.011, 011 times 10 to the hat sign 23rd. Okay, and this will be atoms. Okay, AL, but divided by 1 gives you exactly the same answer. So that's still the answer right there. Okay, so the final answer here, because you divide this by 1, the final answer here, and let's put it down right here. The final answer here is equals to 3.011 times 10, hat sign 23, atoms of AL. They forgot the atoms AL. All right. Well, you can't put AL, so might as well just stop there. So go ahead, write that down. A lot, apparently. Okay. All right. Because they're going to combine the two in a second. All right, here we go. All right, let's try another one. Okay, look at this problem right here. And again, it's a lot. Okay. How many moles? All right, if you look closely here, how many moles are in. Oh, let me raise it up a bit. How many moles are in 1.8 times 10 to the 24th power atoms of sulfur? Okay. All right. So again, guys, you should see the keyword atoms, and you should know that I need the 1 mole of whatever, which is, what is it? Sulfur S is equals to 6.022 times 10 to the 23rd power, and the keyword was atoms, so atoms of sulfur. So again, if you see the word grams, you calculate molar mass. If you ever see the word atoms, particles, or molecules, go calculate using Avogadro's number. All right. So again, same steps. Okay, nothing goes here. The given goes in the very first box, which is 1.8 times 10, hat sign 24. Okay, since atoms is here, you should see atoms at the bottom right here. Okay, so what goes at the bottom is your 6.022 times 10 to the 23rd. Okay, and what goes on the top should be your 1 mole S. All right, okay. Let's multiply everything at the top. If you multiply everything at the top, you get, I need more space, 1.8 times 10 to the 24th power, 4. Okay. And the unit for the top is moles S, because we don't have space. And the bottom is 6.022 times 10 to the 23rd power. Okay. Let's put that in the calculator. Okay. We're going to put that in the calculator, right? Come back to it in a second. So it's 1. What was it? 1.8. That's it. So again, times 10. So just press E. Again, for the times 10, you just press E. E, and what was the exponent? 24. And then you just press 24. See it? Divided by 6.022 And again, times 10 is just press the E, and you get 23. You see it? That's how it looks like. And then you just press enter. And the answer for this one is 2 point. All right. This time, guys, you don't have to move the decimal place because the decimal place is after the 2. You see it? You just have to round this off. So let's round it off to one number after the decimal place. This would be a 3. So the answer here is simply 3. Okay? So the answer here is simply 3. So again, the answer here is simply 3. Okay? All right. So let's round it off. And then the answer here is simply, what is it again? Simply 3. So let's, the final answer for this one is 3. So this is 3, and don't forget the 0.0 moles of S. See it? All right. I know it's painful and I know it's kind of long, but again, hold on. Now, all right, breathe. We're about to put them together. The one with the grams and the one with the moles. We're going to put them together. Avogadro's number and then the grams, right? Here we go. We're about to put them together now. It's not working. Okay, let's go put them together. Here we go. Look at the next problem. All right. Well, no, not yet. This is another example of the same problem before. Okay, if you look closely, how many atoms? Again, if you see the word atoms, okay. Again, atoms, the word tells you that you need the 1 mole is equals to 6.022 times 10 to the 23rd power. Okay. So look, of NaCl. So this is 1 mole NaCl. And this is atoms NaCl. Okay. Same as always, if you solve this, the given comes from the problem. You don't change it. It's 208 moles. Again, guys, across diagonally, they should have the same unit. So what goes at the bottom? It's the 1 mole. And then the atoms 6.022 times 10 to the 23rd, hat sign 23rd, right there. Okay. All right. So you just multiply the top. Okay. And let's multiply the top. Let's go to our calculator first. So, what was it again? 208. So 208 times 6.022 E 23. And you get, all right. And you start moving again the decimal places. So this is 3, 6, 9, 12, 14, 16, 18. What? 3, 6, 18. 3, 6, 9, 12, 15, 18, 21, 24, 27. It's 1.25 times 10 to the 27. Okay. 1.25 times 10. All right. I think I remembered it. Okay. Might as well just make sure. So this is 3, 6, 9. So this is 12, 15, 18, 21, 24, 25, 26, 20, 21 plus 3, 24, 25, 26. Oh, I was wrong. It's 26. All right. It's just 26. All right. So this will become 1.3, and I erased it again. So this becomes, the final answer is 1.3 times 10 to the 26th power atoms of NaCl. Okay, and that was it, 208. And this is 6.022 times 10 to the 23rd power. And this is 1 mole NaCl. All right, so this is problem number 208. You got 6.022 times 10 to the 23rd, 1 mole, and this is 1.3 times 10 to the 26 NaCl. You got it? Go ahead, write it down before you forget it. Okay, breathe, exhale. We can do this. All right. So the next problem, right? I think the next problem is the one that combines them both. All right, here we go. Still no. All right. Still no. Okay. Wow. All right. Let's do this really fast, right? Let's just do this super fast. For this one right here, guys, how many moles are in 5.75 times 10 to the 25th power molecules of KOH? Again, guys, if you ever see the word particles, molecules, or atoms, okay, that keyword tells you that the conversion factor you're using is 1 mole of whatever. In our case, this is KOH is equals to 6.022 times 10 to the 23rd power. Okay, and this time the keyword is molecules, so that's what we're going to use, molecules of KOH. Okay, all right. Same as always, the solution, go draw the grids. The given goes in the first box. In our case, it's 6.022 times 10 to the 23rd. Again, guys, you need a hat sign for you all. Okay, you need that little hat sign because 23 is not going to go in there. Okay, all right. So the atoms is the given. Okay, which is wrong. Again, look closely at this problem. It's wrong because the given is not atoms. The given is molecules. So let's correct this. There's too many wrong things on this worksheet. Molecules. Okay. So it's 6.022 times 10 to the 23rd at the bottom. Oh, wait. What was the given again? It wasn't 6.22. I was looking at the wrong thing. The given was 5.75. 5.75 times 10 to the 25th. I'm sorry because my screen was too small to look at everything. All right. And then 1 mole goes on the top. There you go. Finally, I can see everything. All right. So multiply everything at the top. You get, what was the given again? 5.75 times 10 to the 25th over, multiply everything at the bottom. You get the 6.022 times 10 to the 23rd. Okay. It's not fitting. All right. And then we divide it. So I'm just going to use my calculator over here to make my life simple. So 5.75, don't forget, you have to press the E. 25 divided by 6.022. The E, don't forget, 23. And the answer here is 95.5. The answer is 95.5. And this is moles. Okay, moles of, what is it? KOH? KOH. Go ahead, write it down so you can all see it. So this is 5.75. All right. Let's move on with the problem. Again, I'm doing 4.1 with all of y'all just to make sure that you don't miss anything and that we can look at any errors in the questions, all right? All right, here we go. This is the part that combines them both. All right, this is a bit okay, long. All right, this one is the one that combines them both. Let me just go raise this up a bit. Okay, y'all look at this problem right here. It says there, how many atoms are in 15 grams of magnesium? All right, if you look closely, guys, there are two keywords here. All right, let's go for the first keyword. You should see the word atoms. Y'all see that? Okay. Again, guys, as soon as you see the word atoms, what you should see, what you should calculate is your 1 mole. Okay. In our case, mg is equals to 6.022 times 10 to the 23rd atoms mg. Okay, again, If you see the word atoms, you should know that that's your conversion factor. But wait, if you look closely, there's another keyword, the keyword grams. Okay, the keyword grams. Okay, therefore you need to get the molar mass. This is 1 mole of Mg is equals to how many grams of Mg? And that's what we need to calculate. So again, Mg. It's not gonna Mg. All right. So how do you calculate again molar mass? Count the number of atoms. Mg is only 1 times what's Mg? 24 what? 0.3. So this would be 24.3. All right. All right. So look here. Okay. Since you have two conversion factors, and this is super important, right? This is the part that gets crazy. Since you have two conversion factors, guys, you have to extend your solution. Oop. You have to make it a bit longer. What does that mean? Remember, guys, before we would do only this quadrant right here. Okay. This time you have to add another set of two boxes. So I'm going to extend this and just add another set of two boxes. You see it? Because again, remember, the first two boxes will be for your first conversion factor. The second one will be for the second one. Okay, the question is, which goes in first? Okay, all right, let's figure this out. So again, the more conversion factors that you have, the longer is your boxes and squares. All right. So the given is always from the problem. It's 15 grams of Mg. Okay. So look, remember what I told you? All right, you all focus on this one. Boxes across diagonally should have the same unit. Okay. So I need the conversion factor that has grams. Which one has the one that has grams? So again, I need a conversion factor that has the word grams because the given is grams. So which one is it? It's this one right here. Y'all see it? You see it? That has the word grams. So I'm going to use that first. So I'm going to use that one first. So it's 24.3 grams at the bottom and then 1 mole at the top. So again, I just use that first conversion factor because I have grams. All right. Now look. Look again. All right. Now look at your top box for your conversion factor. You see this? This is mole. Again, boxes across diagonally must have the same conversion factor. I mean, the same unit. Boxes across diagonally. All right. You see this? Okay. So we need to use now the last conversion factor. This conversion factor is our last one. So where do we put 1 mole? It's going to be at the bottom. Again, because boxes across diagonally must have the same same unit. Okay, so what goes to the top? It's the 6.022 times 10 to the 23rd power atoms of Mg. Okay, all right, that seems long. Okay, now we need to multiply. All right, you all multiply first everything at the top. Okay, you go multiply first everything here at the top. So multiply the numbers. So I go 15, so that's a 15 times 1 times 6.022 E 23, and I get 9 point and I get 9.033 times 10 to the 24th. Okay. And what will be the unit? Oh, I forgot. The grams here cancel with the grams here. The mole here cancels with the mole here. Okay. So the unit here is atoms mg. Okay, and that's just the top. Don't forget. Over, I need to multiply everything at the bottom. Multiply everything at the bottom here. 24.3 times 1 is just 24.3. Okay. And now I have to divide everything. 24.3. I have to divide that number by 24.3. So divided by 24.3 and I get, all right. And the final answer here, which I'm going to write down on the left side because there's no space, is 3.7 times 10 to the 23rd power atoms mg. You see it? So this is when you combine those two types of problems. All right. You would see those two keywords in there, and that tells you you need those two conversion factors. You see it? So again, once you see those two conversion factors, you see those two keywords, you have to use those two conversion factors right there. You see it? All right, write it down. Go ahead before I erase it. So again, guys, the more conversion factors you have, you just keep on adding more boxes, right? Just keep on adding more boxes, the more conversion factors you have. Okay? So this 9.033 times 10 to the 24th over 24.3, and this is equals to 3.7 times 10 to the 23rd. All right. Any questions on this one? No? All right, let's try this out again. Woo, how many more questions do we have? What? There's three more? Okay, breed. Let's look at question number 10. All right, we can do this. All right, hold on. We can do this. Okay. All right. Where's the problem? All right, here we go. It's not fitting. It's not gonna fit. Let's make it smaller. All right, close enough. All right, you'll just have to squint. Okay. All right. The question is, how many grams are in 1.2 times 10 to the 24th molecules of C6H12O6? Okay. All right. Wow. Again, keywords. I see grams. Therefore, you have to do the 1 mole of what is it again? C6H12O6 equals to how many grams? That's glucose. C6H12O6. All right. Let's do the calculations for that. So let's do the math on the left side. So I got carbon, I got hydrogen, I got oxygen. I got 6 of this, C6H12 of this, and 6 of this. And then you multiply it by their mass. This is 12, this is 1, and this is 16. All right. So this would be 12. No, 6 times 12 is what? 6 times 12 would be 72. Where's my calculator now? 6 times 12. Since I don't believe myself, it is 72. Okay, 12 times 1 is 12. And then 6 times 16 is equals to 96. Add them all up. So 96 plus 72 plus 12 is 180. Okay, is 180. So this is 180.0 grams of C6H12O6. All right. Oh, Lord. Let me erase this. So again, guys, that's how you calculate the molar mass. Don't forget. Count the number of atoms multiplied by its atomic mass and then get the total. Let me erase this because this is only on a scratch paper. All right. So let's look at the problem again. All right. The other one is, you see the other keyword there? I see the other keyword, which is molecules. Okay, there are two keywords here. And if you see the word molecules, you remember you need 1 mole, okay, of C6H12O6 is equals to 6.022 times 10 to the 23rd power molecules of C6H12O6. All right. Okay. So let's start filling in the answers for this one. All right. Molar mass of C6H12O6. The mass of carbon was what? 72. Okay. Oh, no. Mass of carbon is 12 times the number of carbon was 6. Mass of H was 1 times 12. Mass of oxygen was 16 times the number of oxygen was 6. That is confusing, but we know it's 180. All right. Here we go. Hey guys, I'm just gonna draw my own boxes and squares because I'm just gonna draw my own boxes and squares. No, because I need to raise this up. Might as well just use this. All right, here we go. All right. So the given, don't forget, there's nothing here. Okay, the given is 1.2. So this is 1.2 times 10 to the 24th power molecules. All right. So again, guys, boxes across one another. So this is molecules. Okay. If this is molecules, diagonally across it should also be what? Molecules. All right. And therefore, the boxes are wrong. So you see this? Okay. So this should be molecules right here. Okay. If you look closely, which one has molecules? Let's look. It's this one right here. So what goes at the bottom should be 6.022 times 10 to the 23rd molecules. Okay, it's not going to fit. How about I just write it down again, all right? Might as well. C6H12O6. Hey, you see the top? It shouldn't be grams. This is wrong. It should be 1 mole. That is absolutely wrong. Okay? Whoever did this should be anyway. Okay. And remember guys, again, boxes across should have the same unit. Therefore, the bottom one should be 1 mole. Okay. And since we already have used up this conversion factor, we're going to use the other one. So the other one is 180 grams. Okay. Of C6H12O6. All right. And there you go. That's how it should work out. So let's multiply the top. It's 1.2. All right. Second function, comma, 24 times 1 times 180. And the top is 200. And I'm going to change the color so we can see it. The answer at the top is 2.16 times 10 to the 26th power. And the unit, if you look closely, everything else will cancel out. Molecules here, mole here, mole here. The unit is grams, okay, which is the correct unit, C6H12O6, okay, over, multiply everything at the bottom, is just the 6.022 times 10 to the 23rd, okay. Oop. And I'm going to put the answer on the other side, right? So divided by 6.022 second function, comma, 23rd. And the answer is 358.7 grams of C6H12O6. And there you go. And that is the answer for this entire thing. Wow. Okay. Wow. All right. No. I'm just going to write it down first. Okay. Wow. 1.2 times 10 to the 24, 1 mole, 6.022. All right. Okay. Let me show you how to use the calculator first. Okay. When you multiply everything at the top, then divide it by everything at the bottom, just use parentheses, all right? I'll show you how this works. So, let's go to the calculator at the top. So, use a parentheses. So, let's use first a parentheses. So, we're going to do everything at the top first. So, I'm going to click on this parentheses. Is that a parentheses? Because I can't see it. Which one is the parentheses? This one? All right. So the top was 1.2. So let's multiply everything at the top. 1.2. And again, it's times 10 to the 24th. So E24 times 1 times 180. This is on the top. Okay. close parentheses, divided by, and then do the bottom, multiply everything at the bottom, is 6.022. And again, that's times 10 to the 23rd, 3, okay, times 1, close parentheses. All right, enter. So this is how you put this in the calculator. All right, let's double check. Enter, and the answer is, what's the answer? 358.68. So this is 358.7. 0.7. And let's compare that to our answer. That's correct. You see that? All right. Hold on, guys. We're just two problems away. Just two more problems away, and then we're done with this thing. All right. So I'm going to correct this because this is wrong. This is question number what? The boxes are wrong here. Number 10 was wrong, and then this was also number 9 was wrong. Okay. All right. I'm gonna change it. Let's do the last two. All right. Hold on. We're almost there. How many more questions do we have to do? How many more questions do we have to do? It doesn't show me anymore. This is the last question. Thank you. All right. So look at this one right here. So again, guys, one more time, right? If you see, you have to look for the keywords. How many atoms? All right. As soon as you see the word atoms, remember you have to do the 1 mole, okay, of whatever. In our case, it's copper, Cu, is equals to the 6.022 times 10 to the 23rd. And this is, again, Avogadro's number. And again, whatever keyword you have, that's the one that you're going to use. Atom, Cu. Okay. In 35.4 grams. All right. I see another keyword, grams. Therefore, I need to do the 1 mole equals to grams. 1 mole of Cu is equals to the molar mass. What's Cu? How many grams is that? 63.5. So 63.5 grams of Cu. All right. Okay. So this is 63.5. Two conversion factors. Therefore, we're going to extend our 63.5. Okay. Two conversion factors. So again, when you do this, instead of just a grid, add another 2 boxes like this. Okay. All right. The given, one more time, is 35.4 grams of Cu. Again, nothing here. Boxes diagonally across must have the same unit. Check. All right. Therefore, again, the next boxes, these boxes, guys, are conversion factors. So therefore, you look at your conversion factor, which one has the grams. I see this one has the grams. You see it? And that's what you're going to use. So 63.5 goes at the bottom, and then 1 mole goes on top. Okay. Since we already used that conversion factor, you have to use now the other one for the last two. Again, boxes across will have the same unit. Okay. Therefore, this is 1 mole. And then atoms, if you look closely, it says there's 6.22 times 10 to the 23rd. Okay. Right here. Oh, this is a lot easier because it's cleaner. So again, the units cancel out. All right. And then you multiply everything at the top. Okay. And then you divide by everything at the bottom. So let's put that in the calculator instead of me doing it manually. So this is 35.4 times 1 times 6.022 times 10 to the 23rd. The bottom is 63.5 and 1. All right. I'm going to put this in the calculator, right? So let's go up to the calculator. Again, you must use a parentheses for everything first at the top. So let's use a parentheses for the top. So this is 35.4 times 1 times 6.022. And again, E for times 10, 23. Okay, close parentheses because we're done with the top. And then I have to divide it with everything at the bottom. So divided by open parentheses again for everything at the bottom. So everything at the bottom is 63.5. And then in a 1, close parentheses, right? So this is what it looks like at the bottom. And then enter. And what do you get? I see 335.7. It's a very long number. Okay. If you look at the answer for this one, it's a very, very, very long number. So we have to convert it to scientific notation by moving again that decimal place. Okay. So let's figure this out. So let's start moving decimal places. All right. Times 1. Let me put it in my calculator here because I can't see that far. All right. Divided by. Someone's going to ask me, Mr. Chua, where am I going to use this? One of these days, there's going to be an Asian guy with a mask on, with a baseball bat, asking you, what's the answer to question 10? What's the answer to question 10? You better know what that answer is. All right. So the answer is for this one is 3.36. We're going to round it off to 3.36 times 10 to the 23rd power. Okay. If you move that decimal place to the left, such that there's only one number before it, and then rounded off to the correct number, it's going to be 3.4 actually, 3.4. Okay, so the final answer for this one, after so much pain and suffering, is 3.4 times 10 to the 23rd power, and the unit for this will be atoms of Cu. Okay, and there you go. Okay, write it down. I think we got like 3 more problems here. Ready? Breathe. It's okay. It's okay. For the homework, I'm gonna don't start on it yet. I'm looking at what I'm looking at right now. I'm gonna change the homework. We're gonna make our own. I'm gonna make it into drop boxes. All right, drop down boxes because yeah, just don't do the 4.2 until the end of lunch. All right, I'm just gonna change it really quickly. I'm gonna make everything as a drop down box. All right. It's okay, guys. It's okay. All right. Here you go. This is the last. Hopefully, this is the last problem. There's how many more? There's only 12. Oh, thank you, Jesus, for the love of God. All right. This is 12, right? Oh, thank you, Lord. There we go. Read again. Hopefully, you learned all the keywords that I'm trying to tell you. All right. Again, when you read the problem, how many grams? Oop, keyword grams. Therefore, you need 1 mole of whatever this is, KOH again, is equals to how many grams of KOH. Okay, and we need the molar mass of KOH. So you better know how to do that now. So K, O, and H. There's only one of each. And then you have to multiply it by their mass. K is 39.1. O is 16.0 and H is 1.0. Okay. So this would be 39.1. This would be 16 and this would be 1.0. Add them all up and what do you get? 39.1 plus 16 plus 1 and I get 56.1. Okay. And that is my molar mass. 56.1. Again, guys, if we do it their way, mass of K is 39.1 plus the mass of O is 16 plus the mass of H is 1, and this is 56.1. The only reason I don't like the way they do it is because they never show the number of atoms if it's a one, and it doesn't make sense for people. It's like, how did they get this? So you have to actually number of atoms times atomic mass, right? We have to be consistent in how you do it so that it's going to be muscle memory for you later on in life. All right, but wait a minute, are we done? No, because if you keep on reading the problem, I see another keyword, molecules. And remember, as soon as you see the word molecules, what you need is 1 mole of KOH is equals to 6.022 times 10 to the 23rd power molecules of KOH. Okay? So two conversion factors again, which means when we do our boxes and squares, which is this, we have to add another set of two boxes like this. Okay? All right, let's do this thing. I'm excited because this is the last one. So this is 5.75 times 10 to the 25th. Okay. All right. So again, look at your unit. Look at the unit of the given. It's molecules. Remember, across it diagonally, you should have molecules, which is wrong again. So I have to change again this number 12. Change number 12. Who made this thing? Not me. It wasn't me. Wrong. Okay. So the bottom should be, the unit for the bottom should be molecules. So this is molecules. All right. Molecules. Okay. So look for the one that has molecules. All right. So we're going to start with the red conversion factor. So this conversion factor right here. Okay. So what goes at the bottom is your 6.022 times 10 to the 23rd. And then at the top, it's not that. It should be 1 mole of KOH. Don't forget that. Okay. And I'm 100% sure that the units here is wrong. Okay. All right. Now look, again, since we only have one more conversion factor, the purple one, okay, just look at the unit at the top. Remember, they have to be the same at the bottom. So this should be moles right here, mole KOH. Okay. So we're going to put our 1, take that out, mole of KOH. And then the top number should be grams of KOH. Because that's what we're looking for. We're looking for how many grams. So the last box should have the unit that you want. So 56.1 should go here. Okay. And then you multiply everything at the top. Okay. Let's multiply everything at the top, which is 5.75. Okay. Which is 25 times 1 times 56.1. And then divide everything by the bottom, which is 6.022. And I'm just going to put in the last answer, right? And the answer here is 5,356.6 grams KOH. And that's the final answer right there. Okay. Go ahead, write it down. And let's put in the calculator at the top just to make sure. Okay. This is what, 56? All right. So let's see that in action in the calculator right here at the top. So if you go at the calculator at the top, so let's start first with the top numbers. Again, use a bracket, use the parentheses. So it's 5.75. Again, times 10 is just the E, 23 times 1 times 56.1, close parentheses. And then let's do the bottom. So you multiply everything at the top and divide it by everything at the bottom multiplied. So bottom would be 6.022 E23 times 1, close parentheses, and enter. And the answer is, what's the answer? Oh, I made a mistake. The top should be 25. How do you edit this thing? You can't edit it. I can't see that far. One more time. 5.75. 5.75 E 25 times 1 times 56.1, close parentheses, divided by 6.022 E23 times 1. Enter. And the answer should be 5,356.609. So it's going to be 7, which is, wait, what? 609? 609. Okay, so it's just a 6. All right. And that's it. Wow. Wow, 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 wow. All right. That was very, very long. All right. So, hey, guys, hopefully, for the love of Jesus, if you didn't learn anything today, please go back to the modules. All right. I know it's a bit long. I get the part. Okay. It is a bit agonizing and painful. Go back to lesson. Again, guys, there's a recording. Oh, I'm going to put the recording of the class there in a second. But there are 3 videos there that tells you exactly the same thing. Okay. Teaches you exactly the same thing. Go watch it. Go click on the PowerPoint. Okay. Start on page slide 26. Go review that. And if you have any questions, guys, go ask me. Don't start yet with 4.2. Let me fix it first. I know I already started doing it, but I'm going to make it more streamlined. This is what 4.2 should look like. It should. I know. Don't worry. We're going to fix it. So 4.2 is drop down boxes. I already started on it, so hold on for it for a second. Okay. For the notes, don't worry. There's a lot of errors on some of the questions. I'm going to refix them. I didn't make it, so I don't. This is the first time I saw it as well. So, hey, thank you for bearing with me, guys. All right. All right. Make sure you do 4.2 over the weekend, all right? Because we have a